Very short video today because it's all the same stuff we were doing yesterday but in reverse. So remember, we have the postulate, if parallel, then CA congruent. Then we have all the theorems that come from it. If parallel, then AIA congruent. If parallel, then AEA congruent. And if parallel, then CIA supplementary. Today, this video is all about the converses. So, if parallel, then CA congruent. If CA congruent, then parallel. If parallel, then AIA congruent. If AIA congruent, then parallel, and etc. I don't think I have to write them all out, but I will. If AEA congruent, then parallel. And lastly, if CIA supplementary, then parallel. Remember, the linchpin on the left side was if parallel, then CA congruent. That these theorems down here were proven with this postulate. The same is true over here. We have a postulate that says if CA congruent, then parallel. The rest are theorems that, you guessed it, are proven with this postulate. So without these two postulates, none of the relationships about parallel lines that we know and love and hold true in our Euclidean universe are true. So they are built on this idea of something we cannot prove. So just to see these all written out in nicer form, corresponding angles converse, I'm just going to say if CA congruent, then parallel. If two lines are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel. Then you have all the theorem converses that you will prove in class. And then you have an interesting theorem that I've actually given a test question about before, the proof of, hint, 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 is the transitive property for parallel lines. The transitive property works for equality. We can prove it for parallel lines, and you will do that probably on the next test. If P is parallel to Q, if Q is parallel to R, then we know P is parallel to R. That is the transitive property for parallel lines, and like I said, it is something that we will prove probably on a test. So that's it. The only difference on your classwork will be something like this. They'll give you two lines, they'll cut them by a transversal, they'll say this is 2x minus 5, let's say 50, and this is 3x plus 10, and I don't know if this is going to work out, and they're going to say find the value of x so that line L will be parallel to line P. And for line L to be parallel to line P, we would have to know that this angle here is congruent to this angle here. And if 2x minus 50, then this is 2x minus 50, and that means 5x minus 40 has to equal 180. I got that because I have a linear pair, and linear pairs are supplementary by the linear pair theorem. That means 5x is equal to 220. That means x is equal to 44. And so now we found the value of x that makes these two lines parallel. If x is any other value, it's fine. It just may mean line L and line P look something like that. Or it may mean that line L and line P look something like this. The only way line L and line P get these little marks to show that they're parallel would be if x is 44. Short video, you're welcome. Study for your quiz, both in physics and in math. Peace!